Okay guys, this is the lesson video for 8.3 on trigonometry. Alright, so we're going to understand by the end of this lesson what the sin, the cos, and the tan key on your calculator mean. Alright, and we don't pronounce it sin, cos, and tan. We pronounce it sine, cosine, and tangent. So the objective is in this lesson is to use the sine, cosine, and tangent ratios to determine side lengths and angle measures in right triangles. Alright, so trigonometry is pretty cool. What it's going to allow us to do, and this is just a quick example, if I have a right triangle, alright, and this is just an example of the power of trigonometry. If I know that this side is 4 and this side is 3, I'm going to be able to determine what that angle actually is. So it's going to help us find angle measures of right triangles. All right. In addition, what we can do is also find side lengths. Now, the Pythagorean theorem, remember, we have to know two sides of a right triangle. Well, if with trigonometry, we don't have to know two sides. If we know one side, say that's 4, and an angle that's not the 90-degree angle, let's just say that's 38 degrees. So if we know an angle and a side, we can find the missing side. Alright, so like I said, trigonometry is pretty powerful. It's really cool, and it's got some real practical implications in the real world here. Alright, so like we just said, if you know certain combinations of side lengths and angle measures of a right triangle, you can use ratios to find the other side lengths and angle measures. In order to do this, like I said, we're going to be using trigonometric ratios. Alright, and those trig ratios are going to be sine, cosine, and tangent. Alright, here's kind of what the definition of those are. I think it's summarized a little bit better in this next slide. So the sine of angle A equals opposite over hypotenuse. The cosine of angle A is adjacent over hypotenuse, and the tangent of A equals opposite over adjacent. Right? And so you'll see me abbreviate these like this. So the sine of A equals opposite over hypotenuse. The cosine of A equals adjacent over hypotenuse, and the tangent of A equals opposite over adjacent. Alright, and so how are we going to remember this? We're going to say the word SOHCAHTOA, okay, and that's going to help us remember our definitions of the trig functions. So the S stands for the sine, the O is opposite, the H is hypotenuse. So is sine equals opposite over hypotenuse, the C is cosine, the A is adjacent, the H is hypotenuse, so cosine equals adjacent over hypotenuse, and then tangent equals opposite over adjacent. Alright, so let's do some examples and bring a little bit more clarity of what these mean. So in problem 1, we need to determine the sine, cosine, and tangent ratios for angle T. Okay, so first things first is to find angle T. Alright, so angle T is right here. Alright, so we're going to write down the sine of T. That's going to equal, now what's my sine equal? Opposite over hypotenuse. So opposite over hypotenuse. Alright, now what's opposite mean? Well, here is angle T here, the side opposite angle T. Alright, what is the length of it? The length is 8, so my opposite side is going to be 8, and my hypotenuse, what's the hypotenuse of the right triangle? It is what's opposite the 90-degree angle, so the hypotenuse is 17. So my sine of T is going to be 8 over 17. Alright, now the cosine of T, that's going to equal, so cosine is adjacent over hypotenuse, Alright, so the adjacent side to angle T is the side that's touching angle T but not the hypotenuse. So it's this side right here. And what does that equal? That equals 15. So the adjacent side is 15 and then the hypotenuse is 17. So the cosine of T is 15 over 17. And then finally, the tangent of T is going to equal opposite over adjacent. So what's the opposite side of angle T? The opposite side is what angle T is kind of looking at. It's looking at this side here, which is 8, over the adjacent side. That's the side touching angle T. That's not the hypotenuse. So that's 15. Okay, so those are the sine, cosine, and tangent ratios for angle T. Okay, I paused the video to set up the next problem, the got it problem. So it says use the triangle in problem 1 to find the sine, cosine, and tangent ratios now for angle G. Okay, so now here is angle G. So let's find the sine of G. So that's opposite. So that's the opposite side is 15 over the hypotenuse. So the hypotenuse is opposite the right angle, so that's 17. Alright, the cosine of G, of angle G. So cosine is adjacent over hypotenuse. So what side touches angle G that's not the hypotenuse? It's this side right here, which is length 8. And then the hypotenuse is 17. And then the tangent is the opposite over the adjacent. So the opposite is 15 and the adjacent is 8. Alright, so those are the sine, cosine, and tangent ratios for angle G. Alright, now we would never do we would never find the sine, cosine, and tangent ratios for the 90-degree angle. Alright, it's always the two other acute angles. Okay, we're going to apply some trig ratios here to find distance. In 1990, the Leaning Tower of Pisa was closed to the public due to safety concerns. The tower reopened in 2001 after a 10-year project to reduce its tilt from vertical. Engineers' efforts were successful and resulted in a tilt of 5 degrees, reduced from 5.5 degrees. Okay, now suppose someone drops an object from the tower at a height of 150 feet. How far from the base of the tower will the object land round to the nearest foot? Alright, so we got the dude up here. He's dropping the object. And when he drops it, alright, what we're asked to calculate is how far. Alright, so we're asked to calculate how far from the base will it land. So from here to here, that's going to be our distance x. Alright, so if you want, you can kind of draw that triangle that you see here. Alright, so this is going to be 5 degrees, this is going to be x, and this is going to be 150. Alright, and so we want to find what x is. So you can't use the Pythagorean theorem here, right? Because you only know one side. Alright, but we can use trig because we know an angle measure that's not the 90 degree, and we know a side length. Okay, so now we got to determine what trig function to use. So if we take this angle right here, alright, what is sort of involved in this problem? Well, we have the opposite side involved, and we have this side right here, which is the adjacent side. So we're going to use tangent. So the tangent of 5, alright, so the tangent of 5, we put the degree measure there, is going to equal opposite over adjacent. So the tangent is going to equal x over 150. Alright, and so now we just solve for x, so this should be a 5 in here, the tangent of 5. So now we're going to multiply both sides by 150. So 150 times the tangent of 5 is going to equal x, because that cancels out. So in your calculator, you're going to type in 150, then you're going to hit the tan key, so that's second, no, you don't have to hit second, so it's just going to be the tan key, and then half a parenthesis will show up, type in 5, and then end parenthesis or close parenthesis, and you'll get where's the mode here? Now make sure your mode is in degrees. I'll clarify how to do that in class. But x is going to be approximately 13.2, but we're rounding the nearest foot, so it's just going to be x is approximately 13 feet. Okay, let's get some more practice using trig. So in A, B, and C here, we want to find what W is, and we want to round our answer to the nearest tenth. Alright, so in A here, this is our 54-degree angle. Alright, so what's involved here? So what's involved is the opposite side, and this is the hypotenuse. Alright, so opposite and hypotenuse means that we're going to use sine. So sine of 54, right, is going to equal opposite over hypotenuse. So the sine of 54 is going to equal, now the opposite side is W, we don't know it, and then the hypotenuse is 17. Alright, so now we're going to multiply both sides by 17. So we're going to get 17 sine of 54 equaling W. Alright, so we multiply this side by 17 to get that to cancel, and then we multiply that side by 17. Alright, so in your calculator, you're going to type in 17, then hit the sine key of 54, and hit enter, and you're going to get W is approximately 13.8, rounded to the nearest tenth. Okay, for B, we want to find W again. So notice here we have our 28-degree angle. What's involved? This is going to be the opposite, and then here's the hypotenuse. Alright, so that's nothing. So this must be the adjacent side. Alright, so let's set up our equation. And so sometimes you'll see this. So you'll see sine of theta. Theta, just what theta is, theta equals your degree. Alright, so sometimes you'll see sine of theta, and that just means that's where we're going to plug in our degree. So sine of theta equals, well, whoops, this is my bad. We're not going to use sine, alright, because we're using adjacent and opposite. So opposite over adjacent is tangent. So we're going to say the tangent of theta equals opposite over adjacent. So the tangent of 28 is going to equal 1 over W. Alright, so now what we got to do is get W out of the denominator. So we're going to multiply both sides by W. Alright, so those cancel. So I'm left with W tangent of 28 equaling 1. Alright, so now how do you get W by itself? Well, we're going to divide by the tangent of 28. Okay, so that cancels, that cancels. So W equals 1 over the tangent of 28. So in our calculator we hit 1 divided by the tangent of 28, and we get W approximately being 1.9. Okay, and then for the last one, we have to find W again. So here, here's our 33-degree angle. So we have adjacent, and then, no, what am I doing? That's not adjacent, guys. That's the hypotenuse. And why is that? Because it's opposite the 90-degree angle. Come on, focus, Mr. Weber. Okay, and then W here, that's going to be the adjacent side. Alright, so we have hypotenuse and adjacent, so we're going to use cosine. So the cosine of theta is going to equal adjacent over hypotenuse. So the cosine, my theta is my degree, so it's going to be 33, is going to equal W over 4.5. Did I say 45 earlier? Hopefully I didn't. That's 4.5. Okay, so now we're going to multiply both sides by 4.5. Get those to cancel. So 4.5 cosine of 33 equals W. So in the calculator, type in 4.5, and the cosine of 33. Boom. W is approximately 3.8. Alright. Okay. In D it says a section of Filbert Street in San Francisco rises at an angle of about 17 degrees. If you walk 150 feet up this section, what is your vertical rise round to the nearest foot? Alright, so with all or any type of word problem, you want to draw a picture. Alright, so I have, here's Filbert Street rising at a 17-degree angle. Alright, if you walk 150 feet up this section, alright, what's going to be, so this is 150 feet, what's going to be my vertical rise represented here? Okay, so use trig here. So here's the 17-degree angle. Alright, I have a 9-degree angle formed here, so this is going to be my hypotenuse. This is going to be the opposite side, so I have opposite over hypotenuse involved. So I'm going to use sine. So the sine of 17 is going to equal opposite over adjacent, not over adjacent, opposite over hypotenuse. It's getting late, guys. It's 11:49. Alright, so sine of 17 equals opposite over hypotenuse. The opposite is going to be x. The hypotenuse is 150. Alright, and so the sine of 17 equals x over 150. So multiply by 150 on both sides. So 150 sine of 17 equals x. So in your calculator, 150, hit the sine key of 17, and that's going to give me an x approximately being, rounded to the nearest foot, 44 feet. Alright, so right here you rise vertically 44 feet. So that's the answer to D. Okay, final two problems, guys. Sorry this video is long, but this is a very important lesson, so I made it so you're able to just reference back to this stuff if you're ever getting confused. Trig we're going to continue working with. Alright, so this is a good reference video to come back to. Alright, so if you know the sine, cosine, and tangent ratio for an angle, you can use an inverse sine, inverse cosine, or inverse tan, alright, to find the measure of an angle. Alright, so now we're going to use trig to find angle measures here. here we were finding side lengths, here angle measures. Alright, so we want to find what is the measure of angle x to the nearest degree. Alright, so here is angle x in A, and usually when we're trying to find unknown angle measures, we use the Greek symbol theta. Alright, that is that right there. Okay, so what do we got here? So there's theta. Alright, we have involved here opposite, and we have involved here the hypotenuse. Alright, it says what the measure of angle x is, so I guess we don't really need to name this theta, so we can say just the so opposite over hypotenuse, that's sine, so we're going to say the sine of x equals opposite over hypotenuse. So the sine of angle x, so the angle x, alright, boom, right there, is going to equal 6 over 10. Alright, so now how do we find what angle x is? Alright, so we're going to use the inverse sign. So what we're going to do is multiply both sides by the inverse sign. Okay, so by doing that, the inverse sign cancels out the sign, and so I'm just left with x equaling the inverse sign of 6/10. Now, in your calculator, what you're going to do is you're going to hit the second key. So the inverse sign is either the powder blue or the yellow behind the sign key. So you're going to hit the second sign. So and then the inverse sign should come up, and then you hit 6 divided by 10. Hit enter, and so x is going to be approximately, rounded to the nearest degree, so 37 degrees. So, so this angle right here is a 37-degree angle approximately. Alright, last one. We want to find now the measure of angle x again, but this time it is up here. Alright. Okay, so now what do we have involved here? We have the hypotenuse involved, and we have the adjacent side involved. So now we're going to use cosine. So the cosine of x is going to equal adjacent over hypotenuse, so 15 over 20. Alright, so got to get x by itself, so we're going to multiply both sides by the inverse cosine. Alright, so that cancels, so I'm left with x equaling the inverse cosine of 15 over 20. Alright, and that's going to be approximately, type in the inverse cosine of 15 divided by 20. That's going to be approximately 41 degrees. Alright, so this angle right here, angle x, is approximately 41 degrees. Alright, so sorry the video was long, but I wanted to do as many example problems as I could. That way you can reference back to various parts of this video when you're studying for quizzes and studying for your tests, because trigonometry is super important in geometry. Alright, so I hope this helps, guys.